All right, boys and girls, welcome back to the drive-through for a 5-minute lesson on permutations, combinations, factorials, and the counting principle. If I have 2 pairs of shoes, 2 shirts, and 2 pairs of shorts, how many different outfits can I create? So let's just say that our shoes we'll call A and B, okay? And our shirts we'll call X and Y, and our shorts we'll call 1 and 2. So we've got to pick one from each category. So we're going to make an organized list. So we can have AX1, AX2, AY1, AY2. Okay. And that's order doesn't matter with these outfits, meaning 2XA would be the same as AX2. So I think that's all the ways we can start with A. So then we would also have BX1, BX2, BY1, and BY2. And it's a 5-minute lesson, so I got to speed it up. There are 8 ways. Now, where do we get that? Oh, 2 times 2 times 2 is 8. So that is the counting principle. To figure out how many total possible outcomes you can have, you multiply the number of entries from each subcategory, okay? All right, so now let's use ChatGPT to help us understand how to use the counting principle for Chipotle items. Oh, this is great. It's really doing some work for us. Reading all the menus. Just thinking so hard, using so much power. I'll go ahead and pause the video. I thought it would give it here. Just go ahead and give it to me. What's it going to give to me? Come on. So we got 4 items: burritos, bowls, tacos, salads. We have 2 different rices. We have 2 different beans. We have 6 different proteins, 10 different toppings. Look how many topping combinations there are alone. And there are 221,184 different unique Chipotle meals. How about that? Okay, so what you just found out about is that these numbers are going to get huge fast. And what we're going to use are permutations and combinations. Now, the good news is you don't need to memorize these formulas because your calculators are armed with these buttons. But understanding the formulas will be important as you head into statistics someday. So, a permutation is an arrangement where the order matters, okay? So, and we say this as NPR, N permutate R. You take N factorial. I guess I should remind you guys what factorial is. 9 factorial is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? So you take the number of things that you're picking from the bigger group, you take the factorial, and then you divide by N minus R, where R is how many you're picking from. So if I'm picking 3 things out of a group of 10, that would be 10 permutate 3. Okay? We'll go into some examples here later. After all, it is a 5-minute lesson. Now look at the difference. A combination, the order doesn't matter. So we're going to have more permutations than combinations. Just remember that me and Bob as a group is the same thing as Bob and I. But as a permutation, if I am president and Bob is vice president, that's a different arrangement than if Bob is president and I am vice president. And the additional r factorial on the bottom accounts for the number of ways that that group can be organized. If you want to go deeper into this, come see me and I'll explain it to you. All right, so let's just do one example before the end of the video. A teacher chooses 5 students at random from these names shown to work on a group project. What is the likelihood that all 5 names begin with a consonant? So the probability here is going to be the number of ways of all consonants over the number of ways to select 5 students. Okay, sorry. So I don't think order matters in this at all. So we're going to be using combinations. Let's start with the denominator. How many ways can the teacher choose 5 different students? Well, that's going to be 1, 2, 3, 4, 5, 6, 12, 13, 14, 15. There's 18 students, and we're going to choose 5 of them. So that's what's going to go on the bottom. That's how many different ways the teacher can pick 5 students. Now, how many of these have consonants? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so on the top, how many ways can we choose 5 students out of 13 that all have consonants? And, so we're going to multiply, how many ways can we choose 0, excuse me, let me erase this. Oh no, so here, I'll just do it again. On the bottom, we're going to have 18 choose 5. On the top, we're picking just from the consonants. Okay, so how many different ways can we pick? There's 13 consonants, and then that means there are 5 non-consonants. We need both these things to happen. Don't worry, this one is equal to 1. So it's unnecessary for this problem, but you do want to get in the habit of multiplying both of the things that need to happen. So we have 13 different names that have consonants. How many ways can we choose 5 of those names? And you end up getting about 15% for this answer. All right, hope this helps. We'll see you guys soon. If you have any questions, come talk to me. So.